Okay.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. You're done?
Done. All right, I'm going to show you guys how to do your parts per million and percent calculation or percent composition because I had lots and lots of questions about that. Again, if you guys can find a way to print these out or just copy down into a notebook what you're doing, but this is the sheet I'm talking about, this parts per million. It had a note section up top, and then it worked into it. Actually even had some examples for you, but I will show you how to do these. And then it only had about 4 problems, and then your percent composition, the same thing, very, very minimal. This one did not have any direction, and this is actually a lot easier than the percent composition that we did earlier in the school year. This one you won't really care about what the substance is, you just need to identify it as a solute. So that being said, I will start with the parts per million. So again, this is the document that I'm looking at. If you can find a way to print this out or just take your notes in a notebook and get a picture of that to me, I would accept that. So this is the note section. Like I said, most of this is filled out for you. I did that before I put it online, just in the event that I didn't have a YouTube channel. But now that we're doing this should be pretty straightforward. Again, all you're doing is you're taking your mass of your solute, which is that solid part of the solution, and you're dividing it by the mass of the solution in total. So you're taking the solid part divided by what the solid part is when it's dissolved in liquid, and then you need to multiply it by 1,000,000. So that's what that ppm stands for. It stands for parts per million. If you ever see ppb, that's parts per billion. I think you get the idea. But this is an exponent, so that 10 to the 6th represents that million number. So instead of writing out all of your zeros, so what we need to do is just identify our solute and identify the solution. We're going to divide those two and then multiply by 1,000,000. Again, there's some examples here on how to do that, but I will show you one on here. So our first problem says that you have 0.025 grams of lead nitrate and it's dissolved in 100 grams of water. You can assume that 100 grams of water is the same as milliliters. I put it in a mass for you so that you wouldn't get confused. But if you were to use other text, that might say milliliter. And it's asking what is the concentration in parts per million. So all you're going to do is you're going to identify this minority part or this solid as our solute. So that's going to go up top. And you are going to divide that by our solution total, which is here. And then you're going to multiply that by 1,000,000. So if we quick do that, you'll get 250, and then your label is parts per million. And what that is signifying is that you have 250 molecules or parts of this lead nitrate per million parts of water. So again, that should be pretty easy. It's just identifying that solute and then dividing it by your solution and then straight multiplication. Your percent composition will be very, very similar. This is a separate document. This was something else that was shared with you that was called percent composition. So that should be on your Google Drive as well. But this one is going to be done in a very similar way. You're going to identify your solute. So in this case, it's 500 grams of sodium chloride, and it's now being dissolved in 4,000 grams of water. You're going to divide those just like we did before, but because we're dealing with percentages and not parts per million, we will not multiply by 1,000,000, but we're going to multiply by 100. So it's the same thing that we had done before. We don't care about the atomic masses of sodium or chlorine, so you don't have to worry about a periodic table. It's just straight division. When you get this answer reported as a percentage, you should get 12.5%. And so what that's saying is that 12.5% of your solution is sodium chloride. So again, pretty straightforward, but I had a lot of questions on those. Again, I'm preferring that you guys print these out, hand write on them, so I know that you're doing the work yourself, and then submit them to me either on Google Drive by sharing them with me or just email.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science.